we continue our discussion of the slope of a line and equations of lines. Okay, suppose for a discussion that you have a line on the plane and that you know a point on the line. Let's say you know the coordinates of a certain point, x1, y1, those are numbers that you know, and then the slope of the line you also know. Let's say it is m. So the question is, if I give you any other point on the plane, how do you know that that point is on that line or not? So the question is then, what are the conditions that a point must satisfy in order to be on the line? So if I have a point xy, what is the relation between x and y that must be satisfied so that that point is on the line? Well, if the point is on the line, then that means that if I compute the slope between these 2 points, then that should be m. And writing that down, what do we get? We would get then that, let's compute the slope, y minus y1 over x minus x1 equals m. And then multiplying, you will get that y minus y1 equals m x minus x1. And that is the equation of this line. That's the relation that x and y must satisfy if it is going to be on that line. Okay? And that is known as the point-slope form of the equation of a line. And that is a formula that is very, very, very useful and that you should memorize. Okay? You should memorize that. We will use this formula to find the equation of a line whenever we know its slope and a point on that line. So as soon as you know the slope of the line and the equation, and a point on the line, you can write down the equation immediately. Just use this formula. And this formula is used a lot, is used in calculus so often. You really need to memorize this, okay? Now, if you happen to know that the y-intercept of the line is the point 0b, so let's say, for example, that we happen to know the y-intercept, which is the coordinates of that point, let's say the coordinates are 0b, then using this formula, but instead of using this point, using that point, instead of x1, y1, we use 0 for the x1 and then b for the y1, we would get that y minus b equals m, x minus 0. And of course, subtracting 0 doesn't do anything. So you would get y minus b equals mx. And moving the b, you would get y equals mx plus b, which is another version for the equation of a line that is very famous. And it is known as the slope-intercept form. Okay, so it is right here. So when you have solved for y, that is known as the slope-intercept form of the equation for the line. So you see that when you have solved for y, the m, which is the slope, is always going to be the coefficient of x. So whatever is in front of the x, the coefficient of x is the slope of the line, as long as you have solved for y. So that's one way you can figure out the slope of a line. If you have the equation, solve for y, and look what is in front of the x. Look at the coefficient of x. Whatever that number is, that's the slope of the line. Okay, so let's go through some examples. The first example says here, find the equation of the line that satisfies the given conditions. In each case, express the answer in the slope-intercept form. So in the first one, we have to find the equation of the line that passes through the point 0, -2, and has slope 5. Okay, so we know the slope and we know the point. We have the slope and we know the point. Notice, however, that this point is not just any old point. This is actually the y-intercept, because the first coordinate is 0. So that means this is actually the b. Okay, so we have, whenever you have a point on the line that looks like that, that is precisely the y-intercept. So that means this number right here is the b. So that means b equals -2. That is the y-intercept, and you know that the slope equals 5. So then you can just use the slope-intercept form to write the equation of the line right away. And the equation of the line is y equals mx plus b. Okay, but m is 5, b is -2, so that means y equals 5x minus 2 or plus -2. And that is the answer for that. Okay? So if they give you the slope and the y-intercept, you see that's really quick. Sometimes they will not give you the slope intercept like this one. In that case, all you have to do is use this formula instead. Okay, so it is not any much harder. So just use this formula instead. Okay, here's another one. Find the equation of the line that passes through the points -2, -1, and 3, 7. Okay. Unless you're in this specific scenario where they give you the y-intercept and the slope, most of the time, so that means the vast majority of the time, you are going to end up using this formula instead. So this is really the formula that you will want to use most of the time, like the vast majority of the time, if not all the time, because even if they give you the intercept, the slope, the y-intercept, you can still use this formula. So this formula is like universal. Okay. All right, so if we want to use this formula, that means you need two things. You need a point and you need the slope. So first thing we're going to do is we're going to figure out the slope, because we already have a point. We could use either of those. So find the slope. The slope is going to be, well, according to rise over run, this is going to be 7 minus -1. So subtract the y's over, subtract the x's. So this is going to be 8 over 5. Okay, so the slope is 8 over 5. And then you can use any point for your x1, y1. And I recommend that you use the one that has the least number of negative signs, because negative signs are a source of mistakes. Like they tend to mess you up. So I'm going to use 3, 7 instead of this one because it has no negatives. So I want to avoid negatives because it's easier to make mistakes when you have many negatives floating around. So I'm going to use 3, 7. And now, applying the formula y minus y1, this one right here that you have to memorize, y minus y1 equals m times x minus x1. What do we get? We're going to get that y minus y1, so y minus 7 equals m. M is 7 over 5, I mean 8 over 5 times x minus x1, which is 3. All right, and then normally we solve for y, and in fact that's one of the instructions. It says express your answer in slope-intercept form, so that means I need to write it like this. That's the slope-intercept form. So we're going to solve for y. First, you need to distribute here, so this is going to be y equals, so distribute here, 8 over 5x minus 24 over 5, and then you also move the 7. Okay, and you may do that in a calculator, or you may do that by hand. I'm going to do it by hand. So what is -24 over 5 plus 7? So this is like 7 over 1 multiplied by 5 top and bottom. So that would be 35 over 5. Okay, so I multiply by 5 here. And what is that? That is 11, I think. Yes, 11. Negative 24 plus 35 is positive 11. So 11 over 5. Okay, so then this is 8 over 5x plus 11 over 5. Okay, so the answer is y equals that. So let me just do this. Write it like that. Okay, and here's another example. Part C. So find the, again, the instructions are saying find the equation of the line that passes through those 2 points. Now we have 2 points again, but one of the points is, again, the y-intercept. You could either repeat the problem just like this one because you have 2 points. Okay, so you could do it exactly the same way we did it over there. You have 2 points. Or just use the other formula. So let's see. Regardless, we still need the slope. We need the m. We always need the m. So let's find the slope first of all. So m is going to be, subtract the y's, so 4 minus 0 over 0 minus negative 3. So subtract the y's over subtract the x's in the same order. So this is going to be 4/3. So the slope is 4/3, and now you could either use either of these 2 points in the point slope formula, or just notice the fact that you actually have the y-intercept, so that means the b equals 4. Okay, so that's quicker. And then using this, we're going to get that y equals mx plus b. mx, m is 4/3, so 4/3 x plus b, b is 4. All right, and that's that. While working with lines, we should also say something about parallel and perpendicular lines. So there's this basic fact that you should know about parallel and perpendicular lines, which is as follows. Parallel lines, because they have the exact same inclination, they're going to have equal slopes. And that makes sense because if they're parallel, they really do have the same inclination. And if the slope is a measure of the inclination, then that number should be the same. So that's easy to remember, okay? If 2 lines are parallel, they're going to have the exact same slope. If they're perpendicular, the relationship is as follows. The relationship is that the product of their slopes, if 2 lines are perpendicular, the product of their slopes is -1. And best way to remember this is not by remembering that the product is -1, is by remembering then that if you solve for, let's say, m2 from here, so you divide both sides by m1, you get m2 equals -1 over m1. That's the best way to remember this. So if you have, this equation says that if you have one slope and you have the 2 lines are perpendicular, then the other slope is just going to be, you flip and you change the sign. Is the negative reciprocal of the other one. So if you have one slope and you know that the other line is perpendicular, you're going to know then by this formula that the other slope, the slope of the perpendicular line, is just going to be the negative reciprocal of the other one. So you're just going to flip it and change the sign. Flip and change the sign. Okay, that's it. That's also not hard to remember. Okay, so let's do a few examples with that. Suppose that I ask you to find the equation of a line that passes through 1, 1 and is parallel to the line that passes through these 2 points. Okay, so we have two lines are being talked about here right now. One is passing through these 2 points, through A and B. That's not the line we're interested in. We're interested in another line that is parallel to this one. It passes through 1, 1 and is parallel to this one. Okay, because it is parallel, that means it's going to have the exact same slope as the one that passes through A and B. So let's find the slope of the line that passes through A and B. Using the formula rise over run, we're going to get that the slope of the line that passes through A and B is subtract the y's, so 0 minus 2, over subtract the x's, 2 minus negative 2. So this is negative 2 over positive 4, which simplifying is negative a half. Okay, so the slope of the line that passes through AB is negative a half. Now, because the lines are parallel, the line that we're interested in is going to be exactly the same as the slope of that line is going to be exactly the same as M1. So that means M2 is actually then negative a half. Okay, and now we have the slope of the line that we really want, and we have this point. We have the point x1, y1, which is 1, 1. So we have a point and we have the slope. And now using the formula, we can immediately write down the equation of the line. We're going to use the formula y minus y1 equals m parentheses x minus x1. So we're going to get y minus y1 equals m. This is our m right here, negative a half, x minus x1, and x1 is 1. And that's it. That is the equation of the line. It is not solved for y, which is the way we usually give the answer. So we're going to go ahead and keep going and solve for y and simplify. But basically, that's it. That's the equation. It is perfectly correct. All right, so now let's simplify this. So I'm just going to distribute here. This is negative a half x. Negative 1 times negative a half times negative 1 is positive. I have now move the 1 to the other side. You're going to get negative 1 half x plus 1 half plus 1. And simplifying 1 half plus 1, that's 3 halves. So this is going to be negative half x plus 3 halves. Okay, that's the equation of the line. Okay, now we would like to do an example of a perpendicular one. It's really the same idea. Okay, this one says find the equation of a line that passes through 2, 5 and is perpendicular to the line that passes through A and B, where now A and B are these points. A is negative 1, 6 and B is 3, 10. Alright, so we're looking for a line, the equation of a line that passes through this and is perpendicular to the line that passes through these 2 points. So let's find first the slope of the line that passes through A and B. So subtracting y's, that's 10 minus 6 over 3 minus negative 1. That is 4 over 4, which is 1. So the slope of the line that passes through A and B is 1, which means that the slope of the line we're interested in is the reciprocal of that in the opposite. Now the reciprocal of 1 is just 1, and then the opposite of that is negative 1. Okay? But if there has been a half, then the reciprocal would be 2, and then you put in the negative, it would be negative 2. Okay, so just flip and change the sign. Alright, so now we have the slope of the line we're interested in, and we have a point. Our point, they're telling us the point the line passes through is 2, 5. So that's our x1, y1, and now using the formula, we can write down immediately the equation of the line. So The equation is y minus y1. What is y1? y1 is 5 equals m. M is -1. X minus x1. x1 is 2. So now we simplify. This is y minus 5 equals -x plus 2. And then move the 5 over. And this is -x plus 7. We're adding 5. So the answer is y equals -x plus 7. Okay, we're going to do 2 more examples, and we're going to include in the next one, not in this one, we're going to include graphing. Okay, but in this one, let's just do another example where we talk about parallel and perpendicular, and maybe you should stop the video. As soon as we do A, you should stop the video and try B and C. Okay, so here's what this problem says. First of all, find the slope of the line 8x minus 4y equals 4. So now they're not giving us 2 points on the line. If they give us 2 points on the line, then we use the formula m equals rise over run to figure out the slope. But in this problem, they're not giving us 2 points on the line. They're giving us the equation of the line. Now, you could make a sign chart, and I mean not a sign chart, just a chart and figure out 2 points. Just plug in something for x and then figure out what y has to be, and that would be 1 point. Then plug in something else for x and figure out what y needs to be, and then you would get another point, and then use those 2 points to apply the formula rise over run to get m. That's one way. But the easiest way is just to remember that if you have the equation of a line, if you solve for y, then whatever is in front of the x is the slope. The m is what is in front of the x. But that has to be only after you solve for y. Okay, so that means to find the slope of this equation, we have to do is solve for y, and then whatever is the coefficient of x as our slope. So let's solve for y. Move the 8x to this side. We're going to get that -4y equals -8x positive 4. And now divide by -4, you're going to get y equals, remember everything gets divided by -4. -8 divided by -4 is positive 2. Positive 4 divided by -4 is -1. So that is this equation rewritten, solved for y. So that means that the m equals 2. And of course, we don't really need it because they're not asking about it, but that would mean also that the y-intercept is -1. The b is -1. We only needed the slope though. So the slope of this equation is positive 2. Okay. Now, so you know the slope now of that one. Now let's see what part B says. Find the equation of the line that passes through 6, 6 and is parallel to the line in part A. So we want the equation of a line that passes through 6, 6. So that's our point. x1, y1 is 6, 6. And the line that we want is parallel to this line. So the fact that it's parallel means that it has exactly the same slope. If it is parallel, it means it has exactly the same slope, so that means the slope is 2. And now that we have m and x1, y1, we can use the formula to write down the equation. What formula? This formula. Y minus y1 equals mx minus x1. That you have, remember, you have to memorize that. So we get y minus y1, y minus 6 equals m, which is 2, x minus 6. And let's solve for y. This is going to be y minus 6 equals 2x minus 12. Distribute in here. And then add 6, you're going to get y equals 2x minus 6. is negative 12, and positive 6 is negative 6. Okay, and that is the answer. If you get that, you should try part C, which is just a variation, different points, but now instead of saying parallel, it says perpendicular. So it says, find the equation of the line that passes through the point 210 and is perpendicular to the line in part A. Okay, and there you have the line in part A. Okay, let's do it now. So we have the point 210, that is x1, y1. And the line we're after is perpendicular to the line that has slope m equals 2. If it is perpendicular to the line that has slope m equals 2, that means the slope of this one, which is going to be like n2, is you flip and put a negative, change the sign. So this is going to be negative a half. So the slope for this line that we're after is negative a half. And now with that information, we can figure out the equation. So using this same equation right here, we're going to write down the answer here. So y minus y1 is 10, equals m, which is negative a half, x minus x1, which is 2. Now simplify, so this is negative a half x. Pull that up. Distributing here, you get plus 1. Negative times negative is positive, and a half times 2 is positive 1. And now move the 10 over, and you're going to get y equals negative a half x plus 11. Right. Now we're going to do one more example about lines, where now we would like to include graphing. Okay? We're not only going to find an equation, but also graph the line. Okay, first of all, there's another technique for graphing lines that I haven't discussed, but I'm going to discuss it now, and it is using the slope for finding another point in the line. So here's how it works. Okay, so first of all, you want the equation to be like this, in the slope-intercept form. When you have the equation solved for y, you can immediately tell what the slope is. The slope is whatever's in front of the x, which is negative 2. And you also get the intercept, which is the b. But of course, the intercept, we normally write it as a point, so the y-intercept is more properly expressed as a point on the plane, so that means the x-coordinate is 0, the y-coordinate is 3, and that gives us automatically a point for free that we can plot. Here's the 1, 2, 3. There it is. So that's a point on the line. Our line that we're going to just graph passes through that point. And then we don't know how it goes up or down. You have to look at that to know that it actually goes down. The slope is negative 2. Now, but here's how you find another point. For graphing a line, you need 2 points. You're going to interpret the slope as a ratio, rise over run. You have to interpret it as a fraction. Oops, not run, is run. Okay, so that means this number, if it's already a fraction, then good. If it's not a fraction, think of it as a fraction. So I'm going to think of negative 2 as negative 2 over 1. And then from this point, I can get another point by following you can read these as basically an instruction of how to get to another point. So it says the rise is -2. The fact that the rise is -2 means you actually go down 2. And the run, which is horizontal movement, if it is positive, move to the right. If it is negative, move to the left. So that means this one, to get another point in the line, you go down 2, 1, 2, and then 1 over. So that down 2 and 1 over, that point right there is another point on the line. And then you connect these two dots, and that's your line. Okay, that's it. So instead of just using any two random points, you could use the two intercepts, the x-intercept or the y-intercept, or this another way which I really like is start out with this y-intercept and then get another point for free by thinking of the slope as a fraction and following the instructions. So write it out as a fraction. If it's already as a fraction, good. If it's not, then write it as over 1. And then the top is a rise. Positive means move up, negative means move down, and the run is horizontal movement. So if it is positive, move to the right. If it is negative, move to the left. Wherever you land by following those two instructions is a point on the line. Plot it, connect them, and that's your line. Okay, so we're going to repeat that now with one more example. So it says, find the equation of the line that passes through 2, -4, and is parallel. So I'm looking for an equation that passes through this and is parallel to that one. To 5x minus 2y equals 4. Okay, so 5x minus 2y equals 4. What is the slope of that? To figure out the slope of that, we have to solve for y. So let's solve for y. So move the 5x over. So minus 2y equals -5x plus 4. Divide by -2. Divided by negative. Remember, both have to be divided by negative. Negative and negative gives you positive. So that would be positive 5 over 2x. And then 4 divided by -2 is -2. Okay, that means the slope of the line 5x minus 2y equals 4 is 5/2. That's not the line we're interested in, though. We're interested in a line that is parallel. But because it is parallel, it is going to have the same slope. If it was perpendicular, we flip that, so that would be 2/5, and change the sign, so that would be -2/5. Okay, it's parallel, so it's actually the same. And now we also have another point, x1, y1, which is 2, -4. Okay, so using this two piece information, we're going to graph this. So start out with a point 2, -4, 2, 1, 2, 3, 4. 1, 2, 3, 4. That's the point 2, -4. Now use rise over run. Remember, this is rise over run. So from here, I'm going to rise 5 and then 2 over. So 1, 2, 3, 4, 5. Let me do that again. 1, 2, 3, 4, 5, and 2 over. 1, 2. That's another point on the line. Connect them, and you have the graph of your line. Okay?